Okay, so welcome to my first video of the Climbing Chalk series. I will eventually be doing a second or possibly a third project in this summer, just depending how long this one takes. I do only have about 3 months before the school semester starts again, so gotta account for that, and I don't exactly have the most time to put into this every week, but we're gonna try our best. So, climbing chalk, how climbers use it is pretty much they just coat their hands over it or coat it over their hands, and it helps absorb moisture and just gives a bit more added grip when using the holds. And if you're a climber, obviously you know what a difference it can make, especially if you're someone who sweats a lot. Getting sweaty on the wall is definitely not ideal. So, the chalk. Pretty much all chalks in the industry are like 95% or higher, just made of magnesium carbonate, specifically like light magnesium carbonate. Any companies you see that are selling this commercially all use the same basis, which is this magnesium carbonate. And the differences between the companies is the formulas and maybe types of additives that they add to their chalk. I'll be showing you what additives I'm using, and then we'll see how well it can perform against a commercial brand. Who knows? Maybe it'll be better. Odds are it'll probably be worse, but that's the whole point of this thing, right? So, to start things off, here is my magnesium carbonate. This is 1 kilogram of it. This, what can I say? You know, when I said pretty much all companies use it as a base, there's a reason for that. I'm not going to try and completely invent a new revolutionary chalk, so I'm going to start with that same base. The additives I'll be using are tapioca starch. I don't know if you can see that. Tapioca starch. The purpose of this in my chalk is going to be a hydration absorber. So as you can probably tell, the concentration of this will help affect the chalk's ability to absorb sweat off of my hands, especially useful for me. I do typically tend to be a sweatier climber, so that's great. Next up, I will be using white rice flour. This is for a texture modifier of the chalk, specifically more so how it feels on your hands. The white rice flour is going to help give the chalk a softer slash finer feel on your skin. Not sure what the ideal feel will be for me or for people I'm gonna be giving some of this to, but that's why we're doing this as like experiments kind of thing. We'll be testing it and just seeing what people prefer. Next, I have fine pumice powder. So this kind of does the exact opposite of the white rice flour. This is going to help make the chalk a little bit more abrasive. I will be testing both, but I'll also test them individually in the chalk to just see how they feel, how much they affect it. And then at some point, I will figure out a mixture of the two that works best. Yeah, this gives a more abrasive feel. It can also, from what I've seen and read online, and that it can help give a little bit more texture and grip on the holds. We'll see how well that works. And then the last additive I'm going to be using in very trace amounts is allantoin powder. So another thing with chalk, especially with the tapioca starch, is if you're not a very sweaty person, chalk will dry out your hands quite a bit. And in extreme cases, that can cause cracking and just it can do some damage to your skin. So I will be using the allantoin powder. Just again, in very trace amounts, it is going to just help be as like a skin conditioner, just so, you know, for my hands and anyone I give this to, so I don't destroy their skin. That would not be fun. Next, I just have this respirator mask. I'm working with a lot of powders. Don't want to be breathing that in. I have a digital small kitchen scale, just so I can keep track of my measurements. A stainless steel sieve. The purpose of this is for the magnesium carbonate before I mix anything. The magnesium carbonate has different particles of all sizes. This is a 200 mesh sieve. It'll help separate the particle sizes of the magnesium carbonate between particles that are bigger than, I believe, 400 microns versus particles that are smaller than 400 microns. And the reason I want to do that is because the magnesium carbonate, mixing the different concentrations or mixtures of those particles can actually also affect quite a bit how the chalk feels and just how it performs on your hands. Because again, it makes up at least 95% of the chalk itself, right? So, and then I just also have a bunch of mixing bowls and containers just to keep everything separate.